All right, we are choosing to stay. This is chapter 11:1 in the Green Book. We're choosing to stay in this because there are 4 sections. There are 4 sections or 5 sections in the Green Book that are all in one section in the New Book. So we're choosing to stay in this. All right, most of this is a pre-algebra lesson, and we're talking about square roots. So let's talk about, I don't think you need necessarily the definition, but it's an operation that yields a number when multiplied by itself produces that given number. So in other words, what's the square root of 16? 4. When I multiply it by itself, it will give me 16. Okay? So when I square 0, what do I get? 0, right? And the square root of 0? 0. When I square 1, and the square root of 1? When I square 2, it's 4. And the square root of 4? 2. Seems like it's their inverses. Are they?
No.
Why? Yes.
Well, as you go along, like, I don't know, 36 and 6 would be an example.
36 and 6 would be an example. When would it not be? Ryan?
Like if the square root of the number is not a whole number.
Okay, not necessarily a whole number, no, but I'm talking about with whole numbers. Yes? Negative. That's exactly. So if I'm doing all this, if I start with a number, I square it, I root it, it looks like they would be inverses, right? But in reality, if I square negative 3, we get negative 3 squared is 9. When I take the square root of 9, what number times itself equals 9?
3.
Only 3. Only 3, not negative 3. Okay? Because if I put a negative on the outside here, let's say it would look like this. Of course you asked why. No number times itself will give you this result, a negative result. Yes?
But then negative 3, I see your point, but negative 3 times negative 3 is 9. And it follows
Right.
the rules.
But what this is saying is the root of this would mean that no number times itself will give you a negative. And this rule, because for principal square roots, it says it's a number multiplied by itself. When you multiply negative 3 by itself, you get, when you take the root, I always get myself tongue twisted on this. There's no number that will give you, number times itself, that will give you that negative there. So you've got to think about that. Let's look. So we write them in a different way. Okay? We write the principal square root, or the positive square root, which is like the square root of 16 is what? 4. And the way we show that negative root is with the negative outside. Okay? So what this really means is negative 1 times the square root of 16 times the principal square root of 16, which is 4. So negative 1 times that 4 is negative 4. So the square root is not the inverse of a square because it only gives a positive root. It doesn't really deal with those negatives. Now, I want you to think about this. What are my possible solutions here? Or what is the solution? Yes?
10 and negative 10?
Yeah, I can square 10 and I can square negative 10 and I'll get 100. But when I take the root of 100, I only get positive 10, the positive root. Does that make sense?
Yeah.
Yeah.
Okay, I think we're a little confused on this.
So the big thing to remember is that when you're taking a square root, we get one solution. But when we're squaring something, we could potentially have two.
Right.
Because no number times itself will give you a negative.
So why is the negative square root of negative 16 negative?
Because we keep it on the outside. It's negative 1 times the square root of 16.
Okay.
Okay? Now, really what we're going to be working on is estimating. First of all, is this a positive root or a negative root? Positive root, and the root is, the principal square root is 7. What about the next one? Actually, let's start. What's the root, please? Arden?
5.
Be careful.
Oh, I'm sorry, negative 5.
Negative 5, because it's negative 1 times 5. Good. And is it a positive or a negative root?
Negative
Right. That's how we write show 'em. Number 3. Answer, Torres?
It's the square root of 12.
Positive or negative root? Good. Shaylin?
Oh, sorry, 4, and it's a positive.
Good. Next one, Irene?
It's a negative root and it's 6. Negative 6.
Negative 6. Next one? Jake? Oh, I already did that one. That one.
Negative root, negative 8.
Good. And that's a positive root. And then the last one. Ethan?
You said can't be square rooted, right? It can't be.
Yes.
Negative.
So you know what we say?
No square root.
What? We say no real number. No real root. So what that means is, okay, so for all these years, we've been teaching in Algebra 1, you can't take the square root of a negative. But that's really a lie. We're dealing with the real number system, and when the standards changed, they added a new standard, and they added the imaginaries. So when we get the square root of a negative, what we're talking about most of the time when you take a number with a square root, these are irrationals or irrationals are part of our reals. If you get the square root of a negative, it's outside of that group, and it's an imaginary. Does that make sense? And we'll learn how to use that later, but for right now, you're going to say no real root. Okay? No real root. Maybe by Pi Day we'll know, because it has to do with something on my new shirt. Okay?
Yeah.
All right. So now let's look at this. Now, what we're going to be doing is estimating. So when it says estimate, there's a couple different methods, and I want you to learn them all. Okay? One, I use a majority of the time because it's closest to what I do in real life. The square root of 21, this is the estimating method, falls between what integers? What perfect squares? Yes.
4 and 5.
Or what squares? Perfect squares.
16 and 25.
And the square root of 25. So we're going to say that the square root of 21 is somewhere in the middle, right? But all these other squares, the square root of 17, the square root of 18, the square root of 19, the square root of 20, the square root of 21, the square root of 22, the square root of 23, and then we've got the square root of 24 and the square root of 25. Okay? Now, what is the root of 16? 4. And what is the root of 25? 5. So we know the square root of 21 is somewhere between 4 and 5, the integers 4 and 5. I'm going to find the middle. I can estimate almost to the 10th, almost every time, within 1/10. So if I find my middle, the exact middle, I go in 1, 2, 3, 4, 5, 6, 7, 8. So if I go in 1, 2, 3, 4, and 1, 2, 3, 4, is it safe to say that that's the exact middle? Yes or no?
Yes.
Okay, so I'm going to draw a line there. And I call that my middle. And what is the middle between 4 and 5? 4.5. Now, I'm going to estimate. It is extremely close to the middle. So what might you estimate the square root of 21? What? Don't do it. You shouldn't be looking on a calculator. What are you guessing?
Maybe like 4.55.
Okay, he's saying 4.5. I probably would have guessed 4.6. Okay, I'm asking you to be within 2/10. So if you had guessed 4.6, 4.7, even 4.8, I would have accepted it. But had you guessed 4.4, that means you're not using the halfway benchmark. Do you understand? You should be able to guess which band. So as we take the square root of 21, what do we get? 21. Oops. I'm going to say second. 4.58. Didn't I say 4.6? Somebody said 4.55. Does that make sense? Okay, what might you estimate the square root of 24? Yes? 4.9, 4.8. Let's see. Second, square root 24. 4.89. 4.92, pretty darn close. 4/100ths off. So do you understand how we can? I would probably guess maybe the square root of 23 or 22, like a 4.7 for 23. Yep, 4.79. 4.7, 4.8, 4.6. I probably wouldn't go 4.6. I go 4.6 here, 4.7, 4.8. So do you understand what I'm doing while I estimate? Yes?
What happens if the numbers get roots? It's between really big squares.
Okay, so let's take like, what number?
Like, say, square root of 172.
172. I like that. 172. Okay? Square root of 172 falls between, because we don't want to write that list every time, right? What are the perfect squares it falls between? Yeah.
It falls between square root of 169
And
square root of 256.
196. Okay, this is 14. This is 13. Okay, now, here's what I'm going to do. Subtract. Find the difference between here and here. What is it? It's 3 digits away, right? 172 is 3 digits. And how many digits from here? How many? 72, 82, 92, 24. What's it closer to, Ryan?
169.
Is it halfway in the middle? No, it's pretty darn close. I'm going to guess 13.1 or 13.2. 13.1, 13.19, 13.2. Okay, I'm going to take second square root, and we said 172. It's 13.11. I'm pretty close. I'm 8/100ths off. Do you see how, I mean, it's pretty easy to estimate it, and it takes less time. So you guys try the next one. Let's do the square root of, how about 271. Okay, pause the recording and try and find the square root of 271. We've noted, they just said that the square root of 250, they said that 271 falls between the perfect squares 256 and 289. What's the square root of 256, Arden?
16.
And the square root of 289?
17.
So we know our answer is between the integers 16 and 17. How many digits between 256 and 271? What did you say? 15. And how many digits here? 18? So 71, 81, and 8, 18. So, is it halfway? Is it more or less than halfway? It's between the less than halfway. Because look, this is 15 digits. It's closer to this, the halfway point. It's between halfway and the beginning, as opposed to halfway and 289.17. So it's closer. What would you estimate it? It's close to the middle, but not exactly in the middle. So, Preston?
I put 16.4.
16.4, I think that's a good guess. So let me see. Second square root of 271, 16.46. You're 6/100ths off. Okay, it gets to be pretty quick. Who's still having a problem? Okay.
I'm just confused with when we're doing the homework, would we be able to use a calculator to check?
You can check your estimate, but I want you doing this method or you'll be lost the rest of the chapter. Because there's going to be times where don't depend on a calculator. You use the calculator to check. If you have to use it to get the square root, and that's the only way you know how, you're going to be at a loss when I say no calculators on a quiz. Because I'm not going to let you. I'm going to check that you know how to estimate. So, let's look at some of these. Okay, square root of 7. It's between what perfect squares, Ethan?
4 and 9.
Okay, is it closer to 9 or closer to 4?
9.
So what would you estimate?
8.3.
8?
Oh, wait. Closer to 9.
You're right, it is closer to 9, but what's the square root of 4?
Oh, okay. I meant that. Like 3 point.
Okay.
2.7.
Okay. It's almost 2.7, 2.6, 2.8. That's within the correct range. Okay. 32. Irene, where are you estimating it? Falls between what perfect squares?
It falls between 36
And
25.
is it closer to 36 or is it closer to 25?
36, so maybe 5.8.
5.8. 5.6. You're still within 2. It's pretty close. It's not. I would go with the 8s when it's right next to the last one, since the square root of it's 4 digits off. It's still pretty well. 56. Try another one. It's between.
It's between 40 square root of 48.
No. 64 and
Yeah, 64 and 49.
49.
Since it's closer to
It's how many digits from 49? It's 7 digits. How many digits from 64? 8. So it's 7, and it's pretty close to the middle. So what are you going to guess?
like 7.4.
Mm-hmm. Okay, 99 should be so easy. 99 should be easy. Sarah Arnold. 99.
I'm kind of confused.
Okay, it's very close. What 2 roots is it between?
81.
Good. Is it closer to the 100 or is it closer to 81?
100.
So what are you going to guess?
9.9.
Perfect. You get the idea? Okay, now another method. Okay, I want to talk about this. When you see plus and minus, this just means positive 9 and negative 9 is the answer. They're talking about the positive and negative root. What are we going to guess 18 at? It's between what 2 perfect squares? Ryan?
It's between this perfect square 16 and square 24.
Between 16 and 25. Is it closer to the 16 or closer to the 25?
16.
So 4 point what?
3.
4.3, 4.2. And it'd be plus or minus. Okay. Now, what does this mean? Square root of 99 is what? 9.9, right? So this means 2 plus or minus 9.9. 9 and 9/10. Branch it off. It means 2 plus 9.9 and 2 minus 9.9. Now I've got 11.9. And here I have 7.9. So you have two solutions there.
Isn't it negative 1.9?
Oh yeah, negative. Sorry.
So why'd you do that?
What's the square root of 99? Close to 10.
Oh, okay.
Okay. All right. Now, another method you can use. Give me another number.
83.
What?
83.
83. Okay, this is the method that Sophia likes to use and Mr. Peterson. When you need to estimate to the nearest hundredth, this is extremely accurate. 81 falls between what? 83 falls between what perfect squares?
81.
Okay, we know that this is 9, this is 10. It's somewhere between those integers. Okay? So we know it's got to be a 9 point something, right? Now here's what you're going to do. You're going to create a fraction where you find the difference of the middle number and the small number minus the small. And then it's going to be, the denominator is going to be the difference between the large number minus the small. So I'm going to have 9. And what's the difference here between 81 and 83? 83 minus 81 over 100 minus 81. So I get 9 and 2 over, and then we divide it. 2 goes in the doghouse, 17. It goes point, it goes once, it goes once. I have 13. Okay, I don't need to keep going. It's 9.11. Yes?
What happens if the difference? What happens if the numerator? What happens if the numerator is bigger than the denominator?
Put them in order from least to greatest. Okay? Now, how you're checking on the calculator. Don't do this now. Okay. How you check on the calculator. Oh, it's not showing mine. You have to hit the blue key that says second. That will enable anything in blue. And you're going to hit like second, and then you hit the square root sign. Square root. Oops, sorry. And then you plug in the number, like I want the square root of 79. Use this for checking only, not estimating. Huh? I went second, and then I hit, look at, see the, it enables anything in blue. And if I did second, if I do this, just x squared, I could take any number, 6, and hit x squared and it squares it. Enter. If I want to do more than that, like up to the third power, I hit the character. So I say 45, the caret, sorry, and then I could say to the fifth. And that's what the number is. Okay? Okay, now a couple other things I need to go over before you walk out. Other ways, other things that you might see. Okay? Come on, don't do this now. Okay. Other things, let's just... I can go through this quickly. So, if it's not a perfect square, it's considered an irrational root. So 1 is a perfect square and 0 is a perfect square because the square root of 0 is 0, square root of 1 is 1. Square root of 2 would be irrational because it doesn't have a perfect square. Square root of 3, rational or irrational? Right. Square root of 4, rational. Square root of 5. Here's the one, square root of 6. Irrational because it's not a perfect square. Do you get the difference? Yeah. Now, hold on, I'm not done. We said they're either rational or irrational in here. If we get one that's not a real root, it just means it's not part of this, the square root of negative. It's an imaginary. So, when you look at this picture, can you please freeze for a minute? When you look at this, especially in Common Core, they might want to illustrate this. Why is it a perfect square? Because it's a 1 by 1 square. Okay? 4 is a perfect square, a 2 by 2. 9 is the area, but it would be made up of 3 by 3. The root is the side of the square. Okay? 16 would be a 4 by 4. Now, one more thing they may ask you. Here's a way they could ask it. We've already been doing this. Determine what two consecutive integers each irrational root lies between. So the square root of 7 falls between the perfect square 4 and 9. What's the root of 4? 2. What's the root of 9? 3. When they ask for integer, they just want the boundary. They don't want you to estimate. It lies between 2 and 3. Integer is a whole, positive or negative number. This falls between 16 and 25, so it'd be 4 and 5. Okay? Questions? All right.